So if the video is really terrible, hopefully that'll help. All right, so I'm going to go over loops today. So we did if statements. If statements let you control the flow of your program in terms of branching it depending on certain values. So you can do one thing if something is true and do a different thing if something else is true, right? So the if statements allow you to control your flow that way. Loops let you repeat things over and over again. Computers are really good at doing that. And it may sound like something you wouldn't want to do very often, but it happens an awful lot, that you need to do the same thing over and over again a lot of times. And basically, need the fan. So basically what a loop does is just that. It lets you do things over and over again. I'm going to, so as I said, I'm going to do a new project. And it'll be the same kind of console project. We will do, as I said, projects towards the end, because console projects I know are inherently boring, but they do have, they're simpler, and you can get closer to the concept. So I'm going to do loop examples, I think I'll call it. You can call it whatever you want. Console application C#, I'm going to do OK. So we have like 2 more things to do, and then we'll be doing methods, by the way, too. So that'll be our next big kind of leap. Does anybody know? So let's just do a really simple loop. Does anybody know the syntax for a for loop? If you've done JavaScript, you know them. If you've done anything, you know them. So yeah, you start with a for. And then you have to create a counter. I'm going to call it counter, although in real life I usually just say X or I. And you need to give it an initial value. It doesn't have to be 0. And then you have to give it a terminal condition. So there's 3 things here, basically. This is the counter and its starting value. And then I'm going to say, so counter is less than, how many do we want to count? Let's just do 20. And then I'm going to do counter plus plus. And then I'm going to open and close some curly braces. This is another block, like ifs. So it doesn't have a semicolon at the end of it. It has curly braces open and closed for a block. And then you can have any number of commands in here that you want to repeat. So this is a little weird because you have semicolons in the middle, right? Basically, you initialize a counter. It doesn't have to be named counter. It can be named anything. So I said I usually name it I for integer or something. But it can be whatever. You have to give it a terminal condition. When do you stop? And then, anybody know what the plus plus is doing? It adds 1 each loop. So I'm going to do something really boring in here, and I'm just going to do a console read line. And what I'm going to do is I'm going to just output the counter. As I said, it's really boring. What is it not like about read line? Oh, I won't. Write line. Sorry. Usual number of coffees today. So there may be all sorts of little mistakes. I caught a later train than I usually do. All right. So this will be really boring, but I'm going to do a couple of things with it. This kind of loop is there's a term for it, but let's just call it a counted loop. It always does a definite number of loops, right? So in this case, it'll do, what, 21? Well, or 20, because it'll stop at 19. So let's just run it. Isn't that exciting? It counted to 19.
Oh, okay. So I'm gonna start. Oh,
Now I want to show you just, I don't know if I'll run through the whole thing, but I'm going to put a little break there just to show you how the loop works by walking through it a couple of times. So that break, basically this is a breakpoint, means the program will execute to this point, which should be instantaneously to the loop. And I'm going to press enter. So it's there. And if you look at that, the counter is equal to 0. The counter less than 20 is should be true. Yeah, so if I put it on the operator, it says counter less than 20 equals true. And it hasn't done the counter plus plus yet. So if I do F11, it goes through here, checks that, comes down into the loop. Let's get the whole loop up here. I'm trying to lower this a little bit. And then it goes back up to here, and it does the increment, right? So when I look at the counter there, it says 0, but when I press F11, it now says 1. And then it goes and checks the condition. You know, so the counter is 1. Is that less than 20? That's true. So it goes back into the loop. And then it comes back up here. Okay, so counter is still 1, but as it goes to the next thing, counter is 2. Is that less than 20? True. So it goes down here, and it just keeps looping until it's not true anymore. And when it's not true, it will go to the, so I don't know if I can do this 20 times real quick. I'm watching down below for the numbers. Okay, so now this one should be 19. So I'm going to do F11. It's still true. Go back up to the counter. It's 19. When I press this, it's now 20. This now is false. So it'll drop down to the outside the loop. So it keeps looping as long as it's true. Does that make sense? And you'd be surprised how often you need to do things over and over again. And computers are really good at that. I'm going to do a quick, let's do something more interesting in the loop. I'll make a new loop. Get rid of this. That the second problem that I had for you, a lot of you were disappointed it only returned one prime number. So you could do this if I want to do 4. This time I'll call it I equals 1. I is less than 41. Okay, I plus plus, oops, plus plus. And I think it'll, well, it didn't spread it out. You don't have to spread it out, but it might look nicer. 2 curly braces. I always do both curly braces at once because otherwise it's easy to forget one. And then I'm going to say, so int prime equals I times I minus I plus 41. So that equation. Yeah, I do have 42, which won't work. 41. And then I'm just going to do console right line, and I'll just put out the prime number. So now we're looping through it. So it's going to do that equation every time, and this number will be different. It'll start 1, then 2, then 3, then 4, and it'll go all the way up to 40. And I'm still running from last time. Okay, so if I run this, all right, so it does my count to 19, and then it starts 41, 43, 47, 53, 61, 71, 83, 97, 113, all the way up to 1601. So I said that equation is just an oddity. It produces a whole bunch of prime numbers in a row, but it doesn't predict any prime numbers before it, and it doesn't predict any prime numbers after it. After 40, it stops producing prime numbers.
When you're doing the breakpoint,
Yeah.
you get to just cycle through each part.
So if you do the breakpoint, you click over here, and then what you do once it breaks. So then it's F11. So if you look up under debug, step into is F11. Step over, like if you want to skip something, is F10. Step out of it altogether is Shift F11. But these are basically, F11 basically gets you through the step by step. Debugging can be really tricky. As I said, we'll look at it more when we have more to debug. But okay, so that's a for loop. The one thing I want to show you about I'm going to do a third for loop. This one I'm going to say console right line. How many loops do you want to do? And I'm going to basically just do int number equals, and I would do a try parse, but I'm just going to do an int parse. So I'm going to get a number. And the only thing I want to show you is that you can do a loop where you do for int equals, and you could start at 1 or 0, int I, or x, or whatever you want to name it. Let's do x this time. Equals 1. I is less than, x rather. X is less than number. And that should be x again. It keeps giving me int because I'm writing I and it's not I. And no semicolon there. And we could do whatever we want in this loop. And it will do it. You can use a variable, right, for the limit. Now, there's something terrible that could happen here, but I'll show you. What do I want to do inside this loop? Just output x. I'm going to change this. And then I'm just going to do console right line x. All right. Does anybody know what the minus does? Yeah, it goes back. Count. It subtracts one. It decrements instead of increments. So it basically, I think one of your assignments is to just count backwards from 10 for like a launch. This is what you would want, right? So what happens if I enter a number? I think I might comment these others out for a moment, just so I don't have to see them. So I'm going to enter a number, and pretty much any number that I enter. So I'm going to say 5. And what do I have? Yeah, it's an infinite loop. Because it'll never reach the criteria. It keeps going backwards, so it'll always be less than the number. It'll never reach an end, which can be kind of fun. But yeah, if you slow this down a little bit, you know, all those screens and all the movies where you have all the numbers, right? You know, flowing by, you can make a screen like that. So one of the things you have to be careful of is to avoid an infinite loop. Generally, oh, wrong comment. The dash dash is a comment in SQL. I've been writing some SQL stuff lately. Avoid an infinite loop. Make sure that your criteria, you know, can be met in the loop. So another thing you could do in here is if you do an infinite loop on purpose, and I'm going to show you a different kind of loop. You could say if x equals minus 10, I'm going to do break. Oh, and that needs to be a double equal. So break, what do you think it does? Yeah, it breaks a loop. It pops you out of the loop.
What's double equal?
It means comparison, right? So a single equal means you're assigning a value. A double equal is what you use when you're comparing two values. So at this point, it should only go to minus 10 and then pop out. So I'm going to say I want 40 loops, but it should still just go to minus 10. So you can break out of a loop based on a condition, right? Are there any questions about, let me close that, about these kind of for loops? I'll uncomment these. Yeah, maybe. Does it make sense?
Question.
Yeah.
Why is it like I plus plus as opposed to just I plus?
Well, plus plus is the operator. Yeah, it means increment.
Would I plus do anything?
I don't think it would do anything. I think it just, what? Yeah, I think it might give you an error. Plus by itself, see, part of it is that the computer, what it would assume if you did a single plus is that you're doing addition, and that that you forgot to enter the second. So if you get technical about operators, there are, what do we call them? There are operators that use two numbers. There's a word for that. And then there's mono operators that operate on a single number. Plus plus is one of those. Minus minus. There's a couple of others that are like that. There are lots of operators, and part of it is just that the computer is very literal, so it can't distinguish between a single plus and a, you know, it has to be able to figure out in context what that plus is doing. So that's why plus plus. It's also why equal equal. You know, in the down a little farther down in the here is just to help the computer figure out which one is happening. Now there are some languages that do take the extra effort to figure out by context. Like I think in Visual Basic, and I think in Do you have to be is equal in Python? I think so.
Yeah.
You do?
You do.
Okay. I've just been starting to learn Python, so I don't know. But in Visual Basic, you don't. It figures it out for you most of the time. But most languages do have a double equal for the comparison. All right. So any other questions about 4? There are complications from these, but I'm not going to give them to you right now. There is, so the first thing is setting the criteria, setting the counter, and where is it going to begin? You don't have to begin at 1 and 0. You can begin at 50 if you want. You can start counting wherever you want. This is the terminal condition. Where does the loop stop? And then increment or decrement, right? It actually can do, you can do other operators there.
I was just gonna ask, yeah, can you do anything besides add 1 and subtract 1?
You can, it's rarer. Let me do one more loop, I guess. Because I don't want to necessarily lose this. I believe this will work too. For int, we'll talk about scope in a moment because it is starting to become important. So I can use I again because it's the scope of the other I is limited to this loop. So this I can't be seen. It doesn't see the other one. I'm going to say I is less than 20. And I'm going to say I plus equals 3. Now we haven't seen the plus equal, have we? Did we do one like that?
Are you showing us with the buses?
Yeah. Anybody remember what plus equal does? Yeah, so basically what we're basically doing is we're adding 3 each time. So that should work. I don't know if I want to do everything above again. I'll uncomment them when I post them. But I'll comment it now. So if I run this, 1, 4, 7, 10. So each one adds 3 as it goes. So you can use some other operators. And I think you can actually probably even use an equation there if you can increment it to some extent. Other questions? That was a good question. Trying to think if there's anything else I need to tell you about for loops before I go on to while loops. Yeah. What do you need to
The
see?
last one,
Oh, the last one.
yes.
I don't know how often you'd be doing this kind of thing,
Yeah.
but it's possible you might want to count by 3s or by something else. And minus equal would be the reverse, right? They're actually, I'll just do it as a comment here. There is plus equal, there's minus equal, there's times equal, and there's division equal, and there's modulus equal. I don't know how often you will use them, particularly, most of the time it's plus equal. Minus equal is the same thing, it's just, say, number equals number minus whatever you put on the other side. Okay, so minus equal would be is basically equivalent to, let's just write that. Did I spell that right? Anyway. So if I had, you have to put a number let's put a this is just a shorter way of writing this, right? If I did, I'll do one more. Times equal to is equivalent to number times, or number equals, yeah, I'll fix that. Number times 2. That's how those operators work. You never have to use them. You could always write number equals number minus 2. It's just slightly more efficient in terms of typing. Does that make sense? I mean, this is actually not super important, but it actually does matter a little bit in terms of a couple of things that we're going to do. So what if we wanted to enter a whole bunch of numbers and figure out what the sum and the average was? That's actually one of the assignments. So how do I do it without doing the assignment? Oh, well, if we do the assignment together, it'll make that part easier for you. So let's do a console write line. So did I say how many numbers to enter?
Yes. You did.
All right, so we'll do that. And then we need to get the, now number I can't use again because it's in scope still up above, although I commented it out. I can use it because I commented it, but let's not. Int num. Did I say to do double? Well, I could make that slight difference. Yeah. Yes, it would. You can't have the same name even though they have different types. That's actually a good question too. We haven't talked, we'll talk scope more in a bit. Especially when we start doing methods and things, scopes becomes really important. But we'll do double dot parse. Okay. So what I'm going to do is we'll do a for. The counter, even though you're using doubles, the counter is always an integer. You notice that it tries to help you, and it gives you really bizarre answers because it's trying to keep it from you from having to type. All right, so we're going to do a loop, and I would, inside the loop, I would put the prompt. So we need to enter enter a number. And I need a different. So actually, this one is still an int. I was on the right track. The one we're entering to count will be a double. The counter is num. Anybody have a good name for this one? Number 2. Except it'll be. This is always a punt, but my number. I will post this so you'll have. I'm hoping that you're starting to see patterns, like the parse and the read line and stuff like that. Whenever we want to get something on the console, this will be different in form. In a form, you'd have a label or a text box to get it out of. But in the console, it's always a prompt, which is a write line, and then something with a read line. And if it's a number, you have to parse it to the kind of number that it is. So we are going to, I am going to declare this outside the loop. I am going to declare a double sum equals 0. And maybe I'll do a double average equals 0. And I'm declaring them outside of here for a reason. Again, the scope. Scope is about when can you see a variable and when can you use it. When is the value visible? And its basic rule is that it's basically available within the scope of the block that it's declared. So I is declared in this block, and so I can only be seen between this and this. That's why I can use I over and over if I want, because it's limited to the loop itself. It can't be, you can't access the value of I outside the loop. Does that make sense? It can only be seen inside the loop. One reason I'm declaring these outside the loop is that I want to do something with them outside the loop. If I declare them inside the loop, they will only be visible inside the loop, and I can't. Like my number is only available inside the loop. Does that make sense? I won't be able to access my number outside the loop. We will spend more time on scope. As I said, when we get into methods, it becomes really crucial that you know when you can access a variable and when you can't. That's just sort of a first take on that. I am going to do sum plus equal my number. Yeah, it adds whatever this is to the sum, and it will add it for every loop, right? So at the end of the loop, sum, which I can access because it's outside the loop, sum will have the total of all the numbers in the loop. So let's, down here, I'm just going to do console write line. The sum is, and I'll do sum. How would I get the average?
Sum divided by numbers.
By num, yeah.
How many numbers?
Right. So, but let's, what variable? You're right, essentially.
Is the quotient of sum.
So notice that we have num here. The num is the number of loops, right? So we can basically just say sum divided by num. And notice you can do that in the write line itself if you want. Now, if we started at 0, you'd have to do num plus 1. But we started at 1. So what it's going to do is it's going to loop for as many times as you tell it to. Each time it loops, it's going to prompt us to enter a number. I did the prompt in the loop because otherwise you could do the read line, but you'd have to know to enter the number. It makes more sense to prompt each time for a number. We will create a number. We'll assign a number. It just reassigns whatever the new number is. It just assigns that over the top of the other. So it's not preserving your last number at all. Does that make sense? It's just keeps reassigning to the same variable. Next time I'll show you arrays. And with arrays, you can preserve all your numbers. But then the sum is accumulating all of these into literally a sum. It's just adding them each time you go through. And then we output the sum, and then we just divide by the number of loops to know how many the average is. So let's try that. Question, yeah.
About the scope, so we're kind of working with some inside that block.
Right,
And that is also accessible.
right, because I declared it outside the block.
Okay, so if it starts outside,
Yeah,
you set it and it'll stay.
right. So basically, because I declared this just in its scope is the main method. So from beginning of the main to the end of the main. Does that make sense? Yeah.
Actually, can you comment stuff out?
Oh, you know how you comment? So if you wanted to comment out a lot of this other stuff, there's a really neat button, and you can basically highlight whatever blocks you want. It's right under the help. There's comment out selected lines, and there's uncomment.
Oh, I see.
Yeah.
So, I just ran this just to check things. If you're entering whatever you're entering for numbers, doing one less than that. And I'm wondering if that's because we have it as I is less than num, as opposed to less than or equal to num.
That could be. Yeah. So you probably do want to equal, less than or equal to. Good catch. Because otherwise, so I'm going to comment that. Otherwise, you are going to be one shy, and the average won't be actually accurate. If I do less than or equal to num, then we get the right number. Or the other option is when you do the equation, to do num minus 1. Either way works.
But even so, you're not getting the right number of loops.
Yeah, that's true. I mean, you could do.
Less than or equal seems to fix it.
Yeah, it should. That should fix it. So let's run this. Oh, you know what? I never used average. So there's originally what I was thinking. So you can do the math here, or you could do average equals sum. Just put average. This one actually might be more readable. Let's try it. So I don't want to do a whole bunch of loops. So I'm going to say 5. Enter a number. I don't know.
40.
40?
And keep those enter a number.
Yeah, I know. It does. It will do it for 5 times. Is that right? That seems awful even.
No. Make a simple number so you can divide.
Does that divide equally? I'd have to do a calculator to see. So we got 5, 40. It is correct. Okay. Let's do some numbers that are a little less. So this time I'm only going to enter 3. And I'll do 23, 97, and 13. So we should have, yeah, that's what I wanted to see the decimals. So does that make sense? Loops are really good again for like accumulating things, doing things over and over again. For loop is one of the most common. And there's one other kind of loop I want to, well, maybe two kinds of loops I want to show you that are also fairly common. And they're common across languages. A for loop in JavaScript looks exactly like that. A for loop in C++ looks exactly like that. Most for loops look like that, except in Python, Visual Basic. I think they look just like that in PHP. Anybody doing PHP? Yeah. All right. So these are for loops. Any other questions about for loops before I do a while loop? So one of the things that we're doing in the class too, so we're looking at all the little bits, right? We're looking at commands. We're looking at getting the input and output. We looked at if statements. We're looking at loops. One of the things that'll follow after this, particularly when we start doing methods, is starting together all these bits into something. Really doing much. Okay. So I'm going to show you another kind of loop. So for loops are counted loops. That means they have a definite number preset. They have a limit in them. Even if that limit is a variable, they have a limit, right? There are loops that will continue until some condition is met. That means that the number of loops isn't preset. And these are basically while loops. I could use the same number probably.
So you start a new program, just to go on.
Yeah. So let's do a variable here. What do I want to do? Actually, let's create a variable that's a string, and we'll call it quit, and we'll set its value as no. All right. So while quit, and I'm going to use another thing here that's, have I showed you this? All right, this equals does the same thing as a double equal sign. And in C# you can use a double equal sign when you're comparing strings. But equals is actually more trustworthy when you're comparing strings than equal equal. It just does more to be careful about resolving it. In Java, not that you probably care, you have to use equals when you're comparing strings. Only strings. The numbers, you always use the double equal sign. This is for comparing, just when you compare two strings. Strings are complicated. They may not seem like it, but in the computer, what a string is basically a collection of characters. We'll talk about arrays next time, but a string is just an array of characters. And comparing them is a little more complicated than comparing numbers. That being said, equal equal would also work there. So, and again, this loop, while, so this basically is going to continue until this value changes, right? This loop is going to go on and on. So I'm going to just do something stupid in here, and I'm going to say console write line, are you ready to quit? And I'm going to say couple of things about that. Let's make that lowercase. Case matters when you're comparing strings. A capital letter is not the same as a lowercase letter. particularly in like C# or a language that's strictly typed. So I think like Visual Basic may ignore case, but most don't. All right, so I'll show you a couple of refinements on this in a moment. I'm going to comment again. I'll uncomment all of these before I post it. I'll add other comments. And this is just so that we don't have to see everything as it runs. So I'm going to run this. Are you ready to quit, yes or no? So I'm going to say no. And it goes, are you ready to quit, yes or no? And I'm going to say no. And I'm going to say no. Now, if I say yes, it quits, right? It can also, let's see. I wanted to show you that if I were to say, so I'm going to say no. If I do a capital N, I also quit because capital no is not the same as no. There's a couple of things you could do about that. Anybody have any ideas? You could do, or all right, that's one way you could do it. And that would work. Do I have an extra one? Yeah. What is it not like? What? Oh yeah, bars, not exclamation points. Sorry. Told you, not enough coffee. And then it should have one more print. Okay. That's one way to do it. And that's a perfectly legitimate way to do it. Anybody have another idea of what you might do?
What are those?
This
Yeah.
means or.
Oh. That means, oh, how do I get it?
So they're right above the enter key.
Right. Yes.
Shift and enter.
Shift and
See, people don't do DOS anymore, but these were really important in DOS. They were pipes. So if you were doing batch files or you pipe, you would, anytime you wanted to cause some data to flow through another command, you had to use a pipe to do that. This is computing from the 80s. Well, so could you just do what? You could use the equal sign if you want. I just say this is more reliable. But one of this, so this works. I don't necessarily want to get rid of that, but I'll show you another thing you could do. Trying to remember no, there's a function that'll take it to its lower case. I don't know if I have to say that. I think it's okay just to say to lower. What that does is that even if you enter a capital, it'll reduce it to a lowercase. There's two lower and there's two upper. So you can change the case of it. So I did quit. Where did it like to go? Quit there. Quit this. Quit this something. comment about. And it doesn't like put together.
Oh, that's fine. Fine.
Oh, we had last week. All right, so this is redundant because of this, but there are two different ways of doing it. A couple of things this is really good for, these while loops. Again, one of the things you can do is, let's say that you want a number to be good. I'm going to do another while loop. So I'm going to say, trying to think of what I want to say. I'm going to do, I could do it as a Boolean or I could do it as a number. I'm going to say while bool good number equals false. And I'm going to say int number. All right, so what I'm going to do is kind of do our try parse. And I'm going to say while good number equal false. Now the other thing you could do is just not good number, right? Just put an exclamation point in front of it. And then what I'm going to do is we'll just do a try parse. I'm going to do a console. Console write line. Enter a number. And then I'm going to do good number equals try parse or int try parse. So console read line. Yeah, right. And then with the try parse, you have to tell it where to go if it's good. So I'm going to say number. Why does it not like number? Oh, out. I need the word out. So what this is going to do, and then I'm going to say, just right now, I'm just going to say console write line. Your number is and then just do number. The other thing you might want to, I'm just going to say enter a valid number. Why does it not like number there? Oh, because it doesn't have a value yet. Equals 0. So what this does, this is just sort of on the side with a while, is it's going to come here and basically as long as you don't enter a valid number, it's going to keep looping and forcing you to keep entering stuff. It's never going to let you out until you enter a valid number. Right? Because good number has to equal true to get out of the loop. So let's just try that. I can leave that loop in. So we have, this is just the try parse, but a lot of you have tried, because we didn't have loops. If you wanted them to give them a second chance to enter it, then you had to give them a second chance, and then after the second chance, they were basically out of luck, right? Because otherwise, you just have to keep doing it over and over. Well, this is what it does. It does it over and over and over again until they get it right. So let's start this. First of all, am I ready to quit? I'll show you that the capital works now. Oh, I said no. So I do want to say yes this time. So enter a valid number. I'm going to say 5, and it goes enter a valid number. I'll say 6, enter a valid number. I'll say x2, enter a valid number. So I'll finally enter 8, and then your number is 8. So it doesn't crash the program, but it makes you do it over and over again until you actually follow directions and enter a valid number. Does that make sense? It's kind of neat. I mean, when you're doing kind of. So while loops have a lot of good uses, and the difference between a while loop and a for loop is that a while loop will continue until the condition is no longer true. However many times that takes. If I was really stubborn and kept writing numbers that are not valid, it would go on forever, or until I quit the program. One other thing to know about this, if I were to say bool equals good number true equals true here, what would happen to this loop? If I change this to true right here, what would happen to the loop? It would never execute, right? Because if this was true, when we come down to the loop, this condition would be false. I mean, it would equal true, so the condition would be false, and it would just skip it and come down to here. Right. One of the things about a while loop is that they don't. If the condition is met before you get to the loop, they will never execute. So I want to show you the very last thing I will show you. I'm taking quite a bit of time, but is that there's a variation of the while loop called a do while. And so you have a do, and you have your curly braces. And then down here, I'm going to say while. I think I need parens. Not sure of that, though. Is it while or until? Wow. It's while. Some languages it's until. While good number. It maybe should have a. I think it does need parens. I think I just. No, it's while. What am I doing wrong?
You have the parens around it. The condition gets the parens.
Good number.
Good number gets the parens.
Oh, so there you go. Thank you. You can tell how often I use do while loops. What do you think? I'm going to just put the same code in here. What do you think is the difference between this and the one above it? If I set this to true, this loop would never execute. What would this loop would execute once, right? The difference is that this doesn't test the condition until the end of the loop. So it always does the loop at least once. This one tests the condition at the beginning of the loop. So if the condition is met before, if the condition is false at the beginning of the loop, it never does the loop. The do version, the do loop version, basically does the loop and then checks the condition. So it always does the loop at least once. Does that make sense? It's just a variation of the other. If you want to make sure that a loop always executes at least once, you can do it as a do while. And I think that's about all I have to say about loops, but the other questions, as you work with them, they'll probably come up. Does it make sense? It's just a way of doing the same stuff over and over again. That's something computers are really good at, that people hate, doing the same problem, over and over again. Any kind of iterative thing, it's really useful for looping. The other thing that I haven't done here, and I didn't do with the ifs that we'll have to talk about, is you can have loops inside of loops, and ifs inside of ifs, and you can have ifs inside of loops. So you could have a loop inside of a loop inside of a loop with if statements inside of them. I mean, the structure can get very complicated. The logic is always sort of the same. But for right now, let's keep it to simple loops, and we'll complicate them later. So as I said, I did part of your assignment. I'll comment this and post it. Let me know if the video is really crappy, and I'll try to figure out something else, to fix them as we go on. I'm going to stop the video right now. Most of the videos you may have noticed have a